Good morning. This is Professor David J. De Los Reyes. The date for today is November 21, 2023, and the time is 2:03 p.m. Okay, my topic for this morning will be a continuation of my subject matter, trigonometry, and I am now, or we are now on lesson number 26. So for those of you who are following my trigonometry topic, we are now on lesson number 26. And the title of the topic for this morning will be Solution of Trigo Functions. Meaning, we are given a trigonometric function or equation, and we are asked to solve for the unknown angle. Okay, let's proceed. The subject matter for this morning will be trigonometry, lesson number 26. Okay, and the title of the topic will be Solution of Trigo Functions, or meaning trigonometric functions or equations. Okay, I will try to give you one example problem just to illustrate on how to solve trigonometric functions. If under the study of algebra, we are given an algebraic equation, okay, and we are asked to solve for the rows. Maybe if the given algebraic equation is linear, the problem is just asking for one solution. But if the problem is quadratic, of course, the solution should be 2. And if the equation is cubic, the number of unknowns might be 3. So for this morning, I will be giving example on the solution of a trigonometric function or equation. Okay, I will try to read the problem. Find the value of x. We are given the trigonometric function or equation, secant of x minus tangent of x, and this should be equal to 3/4. So what is given is actually a trigo function. Trigo function or trigonometric equation. Okay, let's try to bring out the solution. The problem is just asking what will be the possible value of x and what will be x equal to. Okay. To bring out the solution, it will be something like this. We will be applying our knowledge of the so-called definition of the different trigo functions, the past lessons we have learned. So if we now try to continue with the solution, I could represent this secant of x here, because the popular trigo functions are actually the sine and cosine. So if we are given other functions other than sine and cosine, I think it's better to replace those functions with their equivalents in terms of sine and cosine, because we are familiar with the relationship of sine and cosine. So if I will try to bring out the equivalent of secant, just think of the so-called, what's the reciprocal of secant? The reciprocal of secant is actually cosine. So instead of writing secant of x, I will place 1 over cosine of x. Secant and cosecant are reciprocals. So secant of x can be written as 1 over cosine of x. Okay? And tangent of x, in terms of sine and cosine, by definition, tangent of any function or any angle is actually the sine of that angle over the cosine of that angle. So this tangent of x can be written as sine of x over cosine of x, and this should be equal to 3/4. Okay? What is given now on the left hand side is in terms of sine and cosine. And luckily, we are given a fraction, two fractions on the left, in which the first fraction is 1 over cosine, and the second fraction is actually sine over cosine. So it seems the fraction on the left can be written as a single fraction, in which the equivalent will be 1 minus sine of x all over the common denominator cosine of x. This is cosine, so we will just take the difference or the sum of the in the individual numerators, which is 1 minus sine of x, and the common denominator is actually cosine of x. This is all over cosine of x, and this should be equal to 3/4. Okay? We cross multiply this one, so 4 multiplied by 1 minus sine of x will be this, and the right hand side will be 3 times cosine of x. This is 3 times cosine of x. Okay? Let's try to what you call this, square both sides. We raise both sides to the second power. Right? The square of the left hand side will be 4, and this quantity is expressed as a product. So if we try to take the square, it will just be the square of the first one times the square of the second one. Right? That's laws of exponents under algebra. So the square of 4 will be 16, and the square of 1 minus sine of x, it's a square of a binomial, right? So it will be the square of 1. The middle term will be 1 minus sine of x times 2, which is minus twice sine of x. And the square term will be the square of minus sine x, which is a positive sine square of x, close quantity. And this should be equal to. For the right hand side, it's still the same. 3 and cosine are actually expressed as a product. So if we try to take the square, it will be the square of 3 times the square of cosine, which is cosine square of x. The square of 3 is actually 9. And the square of cosine will be cosine square of x. Okay? That's algebra. So be sure that you don't commit mistakes with the so-called simplification. Because most of the problems under the study of mathematics is actually the simplification process. If you try to simplify and if you follow the wrong concept, your solution will be wrong. Okay? Expanding the left hand side. This is 16 minus 32 sine of x plus 16 sine square of x. We will, what they call this, transpose this 9 cosine square of x to the left. So this will be negative 9 cosine square of x, and this should be equal to 0. If we try to inspect the resulting equation, it contains sine of x, sine square of x, and cosine square of x. We got a problem. What will be the problem? There are two separate functions, sine and cosine. So to solve for the unknowns, we must have to replace this cosine here by its equivalent. The equivalent of cosine is actually sine square of x plus cosine square of x is equal to 1, right? That was from the what they call this popular identity under the study of trigo, that is sine square of x plus cosine square of x equal to 1. So we will get the value cosine square of x, okay, to be equal to 1 minus sine square of x, okay. We will replace the value cosine square of x by a value 1 minus sine square of x. So this is this is actually the equivalent of cosine square of x. Right? So expanding again, this is 16 minus 32 sine of x plus 16 sine square of x. A minus 9 times a plus 1 will be minus 9. And a minus 9 times a plus sine square, a negative, and a negative, this will not be plus. 9 sine square of x, and this should be equal to 0. Combining similar terms. This is a sine square function. This is sine square function, okay? This is 16, and this is plus 9, so this will now be 25 sine square of x. We combine similar term. What will be the next term? It will be a function that contains sine of x. It will be negative 32 sine of x, okay? So we are done with this. We are done with negative 32 sine of x, and the only missing part now is actually the pure constant term. Is 16 minus 9 will be plus 7, and this should be equal to 0. What comes out is still a trigonometric equation involving sine, and unluckily, the what you call this, the degree is actually of the power 2. So actually, we are given a quadratic trigonometric equations. So this equation here, I place the name TQE, meaning trigonometric quadratic equation. Unluckily, it is quadratic because the highest power of sine is actually second. So to solve this one, we must have to bring out our knowledge on the so-called solution of a quadratic equation. So whether quadratic equation, whether algebraic or trigonometric, the procedure is still the same. I think the best solution here is by factoring. The possible factors of 25 sine square of x will be 25 sine of x and sine of x. And the possible factors of 7 plus 7 will be a negative 7 and a negative 1. Because if negative 7 times a negative 1 is actually a positive 7, right? And 25 sine of x times sine of x is actually 25 sine square of x. Or let's try to check the value of the middle term. The middle term will be minus 7 times sine of x will be negative 7 sine of x. Right? And the other part is actually 25 sine of x times negative 1. That will be negative 25 sine of x. That's the value of the middle term. If we try to simplify this negative, so the overall sign will be negative. It will be sine of x, right? And negative 7, negative 25 will be negative 32. So the overall coefficient of the middle term is actually negative 32 sine of x. So meaning to say, this possible binomial factors is actually the correct one. So the possible binomial factors of this one will be 25 sine of x minus 1 close quantity times the quantity sine of x minus 1 close quantity, and this should be equal to 0. Okay? If we are fond of the so-called factoring algebraic equation, okay, for the factoring of trigonometric is still the same, right? So 25 sine of x minus 7 times the quantity sine of x minus 1 close quantity, and this should be equal to 0. And the proper way on how to compute for the unknown is that take its factor and equate it to 0. So taking the first factor, 25 sine of x minus 7, and this should be equal to 0. Sine of x will be equal to, we transpose this to the right, we divide that by 25. So sine of x will be 7 over 25. And to compute for x without the sine, you take the arc sine of both sides. Arc sine of both sides. Because the enemy of a sine, it should be arc sine. So the arc sine of x will be x, and the arc sine of 7 over 25 will be the arc sine of 7 over 25, which is 0.28. So meaning to say, after taking the arc sine of both sides, this sine and arc sine cancels, so what remains will be x, but there should be an arc sine on the right hand side. So if we try to get our calculator, display 0.28, arc sine of 0.28, what will come out will be 16.26 degrees. That will be our first answer for the value of x. For the second one, I will try to erase this one. Am I still on the camera? For the second one, we get the second factor to, we equate the second factor to 0. Sine of x minus 1 equal to 0. Sine of x will be equal to positive 1. And again, to compute for x without the sine, take the arc sine of both sides. Take the arc sine. The arc sine of x will just be simply x, and the arc sine of 1 will be the arc sine of 1. And the arc sine of 1 is actually 90 degrees. Meaning to say, what angle is that when you take the sine value, it will be 1. It's 90 degrees, because sine of 90 degrees is 1. Right? But I think we will disregard this value of x here, Because if we try to check the validity of the answers, what will come out for x equal to 90 degrees is not an equality. Okay, let's try to check the first one. When x is equal to 16.26, we will substitute 16.26 degrees to the given original trigo function. Secant of 16.26 minus tangent of 16.26, is it equal to 3/4? It seems we are now on the so-called proving of identities, right? We are proving that the left-hand side should be equal to the right-hand side, so it seems we are proving an identity. So there is a question mark over here. Okay? So, and what is secant? You cannot get the value of secant on your calculator. What you can get is actually the cosine. So to get the secant of 16.26, take the cosine of 16.26, take the reciprocal. So secant of 16.26 will be 1 over cosine of 16.26. We could get this value here using the calculator. And for the tangent, no need of rewriting, we could take the tangent of 16.26 degrees immediately. So this is minus tangent of 16.26 degrees. Is it equal to 3/4? 1 over cosine of 16.26 degrees is 1.041665. And for the tangent of 16.26 degrees, it's less than 1. Minus 0.291662. Is it equal to 3/4? If you try to take the difference of this, what will come out will be 3/4 is equal to 3/4. Since they are now equal, we remove already the question mark and we place QED. Okay? It was really proven to be true that the left-hand side is equal to the right-hand side. Quod erat demonstrandum. This is a Latin word. It was proven to be true, right? So this is the correct answer. For the second one, let's try to check if x is really a solution of the given trigonometric equation. So we will just repeat this same process. Secant of 90 minus tangent of 90 degrees, is it equal to 3/4? Secant of 90, we could change that equivalent to a cosine, so 1 over cosine of 90 degrees. Tangent of 90 will be, I don't even memorize the tangent of 90, but I know this tangent of 90 is sine of 90 over cosine of 90. And 1 over cosine of 90 minus sine of 90 degrees over cosine of 90 degrees, is it equal to 3/4? For cosine of 90 degrees, cosine of 90 degrees, it's a pure vertical line. There is no cosine value. The value of cosine of 90 degrees is 0. Right? And for sine of 90 is equal to 1. It's a vertical line. So sine of 90 will be 1. Cosine of 90 again will be 0. And is it equal to 3/4? 1 over 0, if you try to use your calculator, it will be undefined, or it should be infinity. So I'll place it here. 1 over 0 will be undefined, or infinity, big number. And 1 over 0 again will be big infinity. And this, is it equal to 3/4? And a big number minus a small big number which are not equal to each other, it will still be a big number. And this is not equal. I will now place the value not equal. Okay? Not equal to 3/4, so this is false. So x equal to 90 degrees should be disregarded, and the only correct solution for the given trigo function will be x equal to 16.26 degrees. Okay, that's it, guys. That's the way how to solve a trigonometric equation, okay, under the study of trigonometry. Okay, I think this is just more than good enough to illustrate the so-called solution of a trigonometric function. So you just apply your knowledge of the so-called the different definitions of trigo functions, the reciprocal, the so-called fraction equivalent, and you could solve the problem plus your knowledge of the so-called simplification using your algebra. Okay, good morning from Los Angeles, Professor David J.